In this video, we're going to learn how to create an inventory in Unity. Though this video is going to be very long. This is not an easy thing to do by any means, and there are a lot of moving pieces and testing that goes into creating an inventory, but alas, we are going to do it. First thing we have right now is a basic scene with our player. This is some code from another video being reused. None of this assumes that you've watched the other videos, though. Actually, real quickly, I did just finish the other video about checkpoints, so I'm going to take away the part of the code that makes us die after 5 seconds. Anyways, you should watch that video, by the way. It's a good one. Inventory. Very complicated. Lots of moving parts. We have a player and a pause menu and things already. We don't need any of those for the video. I just wanted to have them here so that it wasn't a completely blank slate. But they do not assume that you've seen either of those videos. First thing we're going to do is make a bunch of script. We're going to need a few things because our inventory is going to have the inventory itself. It's going to have inventory slots. It's going to have inventory items that exist in the UI. It's going to have items that exist in the world before you pick them up and after you use them. It's going to have a bunch of things. So we're going to kind of work backwards from there, and we're going to create the items first because the inventory, if you think about it, is just a holder for items, which means that we should probably have a working item system before we have a working inventory system. With that out of the way, we're going to start. Right-click into our scripts folder and create. No, wrong button. Right-click, create. We're going to create a mono behavior script. I'm going to call this item data. In this game, or in this way we're coding it, there's going to be a difference between our items data and our item as an instance. So we're going to create another one called item instance. An important programming paradigm to understand is the difference between data, or more commonly referred to as an archetype, and an instance. Data is basically just the data for the thing. I mean, that's all it really is. For example, if you create a prefab for your player and store it down here, you're storing the data for the player. And then the one that exists in your scene, that's the instance of your player. That's the actual one you're using. The one that's down here is a prefab. That's just like the original or whatever. This is a copy. When it changes the original, it'll change the copy, but I can also make it not do that. As such, in our item data class, we're going to make it store all of the information for our item. The reason we need to do this is because if our inventory was supposed to work across different scenes and we're storing all these item instances, as soon as you leave the scene, the item instances are going to be destroyed because they refer to the one that existed in the scene that just got destroyed. And these item data, we're going to make this something called a scriptable object. And scriptable objects exist outside of scenes on a more global level, and then they get destroyed. And that takes us to the first thing we're going to do. In our item data class, we're going to get rid of everything inside the curly brackets, and we're going to replace mono behavior with scriptable object. It comes to my attention that we could have just, in the scripts folder, right-click, create scriptable object script, but I kind of forgot that was a thing for a second. It's new to this version of Unity. Above here, we need to add a line of code that'll tell us how to access the scriptable object. This is an attribute called create asset menu. It has a couple of settings. File name and menu name are the two important ones we need. File name is going to be equal to new item data, and menu name is going to be equal to scriptable objects / item data, like that. Now, we don't have anything here yet, but I want to show you what this line of code actually did, this attribute, this tag. When I go into Unity now, I'm going to create a new folder called items. Not required, but helpful. And inside this items folder, I'm going to hit create again. And these are all the built-in things in Unity. You can create animations, you can create rendering things, create scenes, whatever. We just created a new type. Under scriptable objects at item data, we can now create item assets. I'm going to create one called potion and one called, I don't know, I'll call it potion 2. I'll make a health potion. I'm not very creative, so I'll do a health potion and a mana potion. But these are our own custom types. Just like you can create audio mixers or scenes or prefabs or whatever. You can make your own custom types. You can do whatever you want with. And here, our item data, we want to figure out what variables is going to be belonging to our items. We could have name be one of them, but these already have names clearly. So we'll skip that. We'll start with a public string description. I could do serialized field private, but I feel like not doing that in this video because it'd be a bunch of items, whatever. This public string description is going to show up as a little one-line string inside of Unity's inspector, which we don't want. We do not want this because your descriptions are probably going to be longer. So for the word public, we can add an attribute called multi-line. And this is going to change it from the one little line there to, as you could probably guess, multiple. Hello? It's not working. I was going to use text area anyways. There's also one called text area. They basically do the same thing. But if I remember correctly, text area is better. I can never get the two straight. Yeah, this one's better. I don't know why multi-line wasn't working anyways. But we're going to confirm it, so maybe it doesn't. Okay. What else is our item going to have? I can't really think of too much more that I want the item to do right now. You can always come back to it later. I always say to plan ahead and like future-proof your code. But right now, I'm not sure how far I'm gonna go in this video, and items are really different between so many different games. Like maybe you click the item and it switches it in your hand. Maybe you click the item and it just activates it. I don't know. It's different for every game. I just wanted to show that adding this public string description here would let me give each item its own unique description now. You could add more. You could add a public string for this sell price, or the buy price, or this how much you can stack into one slot, or something like that. It's up to you. We have this item data scriptable object now. Again, scriptable objects are cool because they're stored in your folder here. But we want something that can also be stored in the scene as some sort of instance of an item that you can actually interact with. So in our item instance script here, we're going to start this one. I'm going to get rid of void start update because I'm not sure if we'll need them yet. We probably will, but I don't care. Up here, we're going to create a public item data and call this data. After writing this line of code, we go back into our sample scene here, and we'll throw an item into the level. We're going to do 2D object, sprite, triangle, and then we're going to throw the item instance script on. The first variable here is called data, and it takes an item data, which means any of the items that we've created in our project folder we can drag in. I'll drag in the health potion one, and we'll see that this item instance now refers to the health potion item data. As I was doing that, I realized we should add a sprite here, because these do not have pictures at all. We'll do that right now. We'll make a, above here, we'll say public sprite. Just because I realized that's probably pretty important. You can always give a sprite renderer to the item instance here, but it won't make much sense in the inventory without a sprite. Now you'll see a none sprite exists on these guys. Anyways, sprite renderer here. Our item instance component, we always want items to have a sprite renderer. So let's do require component type of, type of sprite, oh my gosh, sprite renderer. And then if you didn't watch the video, by adding this line of code here, it means that you cannot add an item instance component without it already having a sprite renderer. If it doesn't have a sprite renderer, it'll give it one. If you try to take away the sprite renderer, it won't let you. I also think that all of our items should have box collider 2Ds. We'll save this because and go back. I want it so when you touch an item for it to go into your inventory, which is why we're going to require the box collider 2D. Notice that this is kind of a unique glitch. You already added the item instance script before you added this line of code here. It actually doesn't add the box slider to it. It's kind of funny. I still can't remove the sprite renderer, but I definitely do not have a box slider on. I probably should. If I do try to get rid of the box slider now, it won't work. But it's kind of funny it didn't actually do what the entire thing that this line of code is supposed to do does. Yeah. Our item instance has a sprite renderer and a box slider 2D now. I'm moving this one higher up because we're going to use it more often. One thing I want to do is whenever the game loads, I want to switch out the sprite and the sprite renderer for whatever sprite the user puts into here. So note that I said whenever the game loads, which means that we're going to put this into our awake function. Under our public item data, we're going to make a private sprite renderer underscore SPRT, and we're going to do, that's actually all we need. In awake, we're going to say underscore SPRT equals get component sprite renderer. And then under that, we're going to say underscore SPRT dot sprite equals data dot sprite. So we're just saying, go into your sprite renderer component that's on this object. That's what get component does. And then we're saying, get the sprite value here that's being used to display this sprite in the game and set it equal to whatever sprite we've listed here instead. So for my health potion, I'll set it to this check mark. And for the mana potion, I'll set it to this square. And since triangle is pointing to the health potion item data, when I play the game, it should change the sprite immediately to the check mark. It's very hard to see, but it is there. And then when I change it to the mana potion, it should become square. Detroit becomes square. Yeah, it does. Okay, so we're all good there. We now have some way to know what item is being displayed. Next thing we need to do is check for collisions with the item. Let's go to the box collider for the item and set is trigger to true, by the way. If you don't know, box collider makes it so things have collision, and is trigger being true means you won't physically touch it or be stopped by it. There's not going to be like a wall or anything that's stopping you from moving through it, but you are going to have code that runs so that the game knows you touched it. Because this item, you want to pass through it, but as soon as you touch it, you want it to go away and go into your inventory instead. So to do that, we're going to create a private void. I mentioned this a couple of the videos by now. We need to do on trigger, and then we're going to do enter 2D. There are a million variations of this function, 12 to be specific. There are ones that say on collision instead of trigger. There are ones that say on stay or exit instead of enter. And there are ones that don't say 2D. Out of the 12, you have to always use the right combination. In this case, on trigger enter 2D is going to run when an object with a trigger, when this object is touching it or whatever. There's also on trigger exit 2D, which would be when they stop touching. You would use on collision if neither object had trigger checked. And then you'd get rid of the 2D if it wasn't a 2D game. But this is going to be what we want, on trigger enter 2D. First thing we're going to do is we're just going to say destroy game object. Game object refers to the game object that is attached, this component is attached to. In this case, the component is attached to the triangle. So on trigger enter 2D, when it starts touching it, it should destroy the game object. So let's try it out. And it went away. It did exactly what it's supposed to do. And I hit the checkpoint from the other video. So now that we have that, we want to store an inventory of items that we've touched. So in our scripts folder here, we're going to create a new MonoBehavior script called inventory. This inventory is going to store data using static variables, and the point of that is going to be so it can carry across between scenes. And I'll explain that in a second, but if you haven't seen the checkpoint video yet, you should, because it explains static variables in good detail. And again, I will re-explain it for this video, but like I also said in another video, repetition is the best way to learn things. You're never going to learn something from only doing it once. That makes no sense. So watching more videos means learning more, in theory. Anyways, item instance, item data, inventory. This might be all we need for the video. I'm not sure yet. But what we want our inventory to do is store a public list. Now, notice there are more than one thing to start with the word list here. We have list, and then we have list. We want this top one under system collections generic. These are both lists that we can use. Only one of these is the one that'll store it in Unity correctly. These scripts are both part of different namespaces, is what it's called. Basically, if I were to list out every single type in C#, there would be literally thousands. And so to organize them, they use namespaces. Like imagine if your computer didn't have folders and everything was just stored in one giant directory, you never find anything. So you have folders to store things in, right? Like desktop, games, stuff like that. These namespaces are basically folders to store code in. The one we want, called list, is stored in the namespace called system.collections.generic. You could type out the full system.collections.generic.list every time, or you could accept the suggestion, and then it would add this line of code called using system.collections.generic to the top of our script. That tells it that anytime we write code, assume that it's going to be part of this namespace, so we don't have to type it every single time. We have a list here. We're going to create a list of inventory. Sorry, we could do item instance, but this would break if we change between scenes. We don't want that. So we're going to have a list of item data instead. And we're going to call this items. And then in our item instance script, under onTrigger enter 2D, before we destroy the object, we're going to say basically add whatever data is stored in this item instance to the player's inventory. To do that, we need to find the player's inventory. So we're going to say find first object by type, assuming there's only one inventory in your scene. And then we're going to add parentheses here, because you always do parentheses after find object by type. And then dot inventory, hello, what is it called? Items, I call it items. Dot items, then there's dot add, oh my gosh, Cobot's being really annoying today, data. This will say, take your list of items and add this one, the data for this one, to the list. Let's try it out. So I'm gonna go my player really quick. I'm gonna minimize all these we're not using right now. And then I'm gonna add an inventory script to the player. Up to you where you want to put this. Typically I probably wouldn't put the inventory script on the player, but maybe your game supports multiple players with different inventories. I'm not sure. Let's get here for now. There's an items drop down here now. I can add or remove things from it, but it probably should be empty. Note that if you wanted to add default items to your game, all you do is add them to here. So we'd say like health potion. Maybe you want to start out with a health potion, you'd add it here or whatever. We're gonna keep it empty though. Play the game. And if I touch the square, it adds the mana potion to my items list. Let's create a few other things to test it out with. One over here, one over here, one over here. I'm gonna give this one the health potion and this one the health potion. I'm gonna test it out to make sure that there should be 2 mana potions and 2 health potions in my inventory after this. Go around collecting them all. I am missing one. Where is this one? It's over here. Now my player inventory has 2 health potions, 2 mana potions. So it all worked correctly. Again, as a recap here, this list just lets me store multiple values except for instead of just one. My item instance here finds the inventory in my scene and adds the data to its list of items. But like I mentioned earlier, this is slightly problematic because there does exist a case where you want to go between different scenes and your inventory would get cleared between scenes, and you don't want that. So if we make it a public static list instead, it'll get stored between scenes. A static variable basically doesn't belong to any specific instance, and that means that every player could not have their own inventory anymore. It's just a generic like list of items that exists in the game now. And this is nice because the list normally would get deleted and recreated when you swap between different scenes, because technically it's a different player that actually has the inventory script. The player in level 1 is different than the player in level 2. They're both from the same like prefab, but they're not the same thing. This is also telling us this line is here broken now. Since inventory items is a static variable, now we need to say instead of find first object by type inventory.items.add, we need to say inventory.items.add. This is also nice because it's a little bit easier to read and write. But anyways, this will add the item to our inventory like it did before now, just without the stopping the game thing. Let's play it and see what happens. If I touch the object, we'll notice an error in my console. Object reference not set to an instance of an object. If I double click the error, it'll take me to the line of code causing it. It says it's this one right here. What that means is that something that I'm trying to use here is null. To be more specific, I'm trying to access a value from something that's null. Null means that an object doesn't exist. For example, basically, a null object, like if I had a dog or whatever, and I was trying to say, get the dog's fur color, and I had a function called find nearest dog, or find nearest dog in a 5-mile radius, or something like that. And there were no dogs in the 5-mile radius. My code said, find the dog in the nearest 5-mile radius, and then print out its name. If it couldn't find that dog, it'd say, there's no dog to get the name of, and it'd throw an error at you. What it's saying right now is there's no inventory items list to add my item data to, which is odd because we definitely see it right here. And the reason is because now that it's static, we need to manually create an inventory. We have to manually instantiate this variable. Lists are a class in C#. And what that means is that your computer's storing this class somewhere in your RAM, and by default, it's going to be stored as empty or null. And to actually create the items inventory array or whatever list, you have to say equals new. This will, instead of having it be null or empty by default, will create a new list by default for it to populate. So now we have a new list that gets created when the game starts instead of the default value of null. So now we shouldn't get an object reference set to an instance of an object error. Let's check out before we assume anything. We see that all the objects are still disappearing. Sadly, now that this is part of the static variables, we can no longer view it in the inspector. So we'll have to do other methods of testing things. Anyways, our items can now store their data. Instances know when they're interacted with, and they disappear when you touch them. Add it to an inventory. Now that we have all the item code out of the way, now we just need to get our inventory to work. This inventory is going to be a drag and drop inventory that you can open up into your game using a grid system or whatever. We're going to use a canvas for this. I'm going to delete the existing canvas in the scene so we can explain canvases from the ground up. A canvas is the parent of all UI objects. And what that means is that everything you do in a UI is relative to the canvas. For example, if I were to create a UI canvas here, and then create a UI text mesh pro here, if I double click the canvas, it takes me to this giant rectangle, which is much bigger to my game than my game's camera. Everything you do in the UI is relative to this. This represents my screen, which means that this is the top left of my screen, this is the top right of my screen, this is the bottom right of my screen, this is the bottom left of my screen. So if I move my text here to the bottom here, it's going to go on the bottom of my screen, and you can't see it because the white background or whatever. But let's say I move it here, this is the middle of my screen, the text should appear in the middle. And if I move it up here, it's top right, it should appear at the top right of my screen. Looks good. What we want to do, we don't want text. We want to create an inventory. What we're going to do is right click the canvas and click create empty and call this inventory. And then we're going to right click UI. I'm going to add a text right here called label. The text is going to say inventory. In the game, with the game view open, I'm going to make some changes. I'm going to hit the SC button, which is called small caps, just because I think it looks nice here. And then bold it real quick. I want the font to be a bit bigger, so I'll choose auto size. And then in a second, I'll resize the bounds for the inventory here. I also want the alignment to be in the middle horizontally and the middle vertically, so I'll select both of those. Now we just need to make the text actually take up the right spot of the screen. To do that, we're going to go into our rect transform component, and we're going to adjust our anchors here. The anchors tell you which part of the canvas this object is relative to. So before we change for label, we should change it for inventory. We want our inventory to take up the full screen. To do that, with our anchors, we need to set the min and max values for the x and y axes. The min and max value, if they're the same, it'll be relative to that one part of the screen. So 0.5 in the x is the middle and 0.5 in the y is the middle. But if I change both these x's to 0, it'd be relative to the left of my screen. If I change both these y's to 1, it'd be relative to the top of my screen. So now it's relative to the top left of the screen. I want it to be relative to the top of the screen. Actually, no, for the inventory, the whole inventory itself, I want it to take up the entire screen. If these numbers are different, it'll stretch between those two values. So 0.25 and 0.75 would stretch between the 25th and 75th percent of my screen's width. What I want to do is stretch between 0 and 1. It'll stretch between the entire screen now on the x-axis. On the y, let's do 0, 1, so it stretches between the entire top and bottom of the screen. With my label here, I want it to be relative to the top, but stretch between the left and right. My y's are both going to be 1. My x is going to be 0 and 1. And then for the height, I'll do 100. And then position, I'll do -50. And we'll see how that looks. I think it looks okay. I'm going to move it -75 maybe. And then the size became 72. I'm going to do 75 for the max, just because I like nice numbers. The min I'll set to 20. This would just be messing with things. No, that's too big. What did I do? 75. There we go. I wonder what happened there. Okay. Inventory here is good. I'm going to add some sort of drop like background to the inventory so everything is like not blending in with the existing game. I'm going to right click the inventory and click UI image, call it background, and change the color from white to black, and then set the alpha to 75. I did this a lot slower in my pause menu video, by the way. You should watch that if you haven't yet. I'll do 0 for the min, and then 1, and then 0, and then 1. You'll notice nothing changed because these margins here also need to be changed. Notice this also covered up the word inventory. You notice in the background. The way that Unity UI works is it draws items from top to bottom, which means that things on the bottom are front of things on the top. So, which is not what you want. You don't want things at the bottom being in front of things on the top. For a lot of people, that's unintuitive. But again, the way it works is it draws this thing, and then it draws this thing, and then draws whatever's after it, which is not what you want. So just putting background above label will draw the background and then draw the label, which will put the label on top. Anyways, so this is all good. Now we're ready to actually start setting up the grid for our inventory. I'm going to right click our inventory, click create empty, and call this grid panel. Reason is we want a panel for the grid to go on. So we're going to add a component called an image component here and set the source image to this background that Unity has built in. And we're going to resize the anchors and everything here until it looks good. I want to stretch the inventory background, the panel thing here, between the 20% and 80% width of the screen. I'll do 0, 0 for both these, see how it looks. I think it looks good. I'll stretch it between the 0.1 on the Y and then 1 on the top. So it's, bottom should be 0. And then I'll give it a top of about 100, I'll do 200 margin from the top. It's kind of weird. I'll adjust this one to be -100. Maybe. I'll do 200 for the height here. Okay. So the inventory label is now 200 tall with -100 on the Y. And the grid panel here, notice that I did 0.1 for the bottom here. I think I'll change it to just 0 and then have 100 margin from the bottom. I want to use good numbers. My label here used 100 value here and 200 for the height, so I'm using half of that for the bottom here. I'm using 200 here to make sure it respects the label and doesn't like cover it or anything like that. Before we go any farther, I want to make sure that our canvas scales the screen properly. So I'm going to go into the canvas object here and go to canvas scaler. You'll see the canvas is set to constant pixel size. We don't want that because in bigger resolutions, everything becomes tinier, which we do not want. So we're going to set the UI scale mode to scale with screen size, which would really be the default anyways. And everything looks weird. Everything looks weird because up until now, we were working in this mode, 1920 1080. So let's set the reference resolution to 1920 by 1080 so we don't have to redo everything. Now, no matter which resolution we work in, it looks the exact same. If the ratio is different, it won't look the same, obviously, but it scales nicely now. I want to add more contrast because right now I'm feeling like these are too similar. So in my grid panel, I'm going to add a shadow component with a 0x offset and -5y offset. And now there is a little bit of a drop shadow, which looks kind of nice too. This is all cool now. Now we're ready to actually add our grid. To do that, we're going to add a grid layout group to this object, and then we're going to create a grid object under it. We're going to right click, create empty, we're going to call it slot, and then we're going to add an image component here as well. We're going to give it the background sprite, and then set the color to be a little bit darker. I'll do exactly 50. This is cool, but it's in a really weird position. It doesn't really look good. So under grid panel, under grid layout group, we have a padding option here. Let's give it some more padding, like 50, 50, 50. That's too much. No, I think 50, 50, 50 is fine. Okay, so it's 50 pixels from all sides. 50 pixels is if you're working with 1920 by 1080. It'll scale for different screen sizes though. Cell is a little small, so I'll change it to 150 and 150. This is good. I'm going to duplicate the slot by clicking Control D over and over again. And then I'll stop right here. With the grid panel selected, there is a spacing value. I kind of feel like I chose the perfect number somehow. I don't know how. 150, 150, and all these other settings made it so it's exactly 7 wide. That was kind of awesome. But I'll start increasing the spacing here so they're not like super claustrophobic. It looks like 30.4 is like the most I can make it on there. So I'll do the same thing for Y. And then I'll get rid of these bottom ones. Oh my gosh, wait, how did I choose such perfect numbers? I don't know how it's like exact, like almost perfectly fitting in there. That's insane. Anyways, so this is all good now with these random numbers I selected. Notice that if I make new things, it won't go off as far as the width of the panel goes. Kind of cool. I wish we would do the same thing for the height, but whatever. With a grid layout component, you also can set if it should be a fixed column count or a fixed row count. Both can be very helpful. Flexible is an interesting setting, which sometimes works how you want it to and sometimes doesn't. You can also change the child alignment. It's all set to the middle center. I thought that would look better. Maybe no top margin. Yeah, if I set top and bottom to 0, then middle center looks good. In fact, these actually shouldn't matter at all anymore. Start axis doesn't matter either right now. Start corner doesn't either. This thing is now perfectly centered in our thing, which means that we can start actually writing code to add things to our inventory. But first, we need to make it so we can toggle our inventory. What we're going to do is we're going to make in our inventory script, we're going to add a couple of functions. We're going to make a public void open inventory and a public void close inventory. What we're going to do here is in our open inventory, we're going to make the object appear, and close is going to disappear. We'll also make a toggle inventory function while we're at it. Most of the time, I try to future-proof my code, and even though if I can't imagine a use for something yet, I'll write it just in case. You can take that too far. Like, I wouldn't add like a whole extra feature to my player if I don't think I'll need it. But if it's something like open and closing, I'll add a toggle just in case. Like, who knows, I probably will need something like that in the future. On my public static items list here, underneath it, I'm going to create a private bool called is open. And then in open inventory, I'm going to say is open equals true. By the way, I went over this in much more detail in the pause menu video. I'll try to explain it in this one well too, but basically what we're doing here is when we open the inventory, we want the isOpen variable, the bool, to become true. When we close it, we want it to become false. When we toggle it, we say isOpen equals not isOpen. What that means is not we'll take the current value, we'll take the value, whatever's after it, and flip it. So if it's false, not makes it become true. If it's true, not makes it become false. So basically, this line will say flip the value. If it's true, make it false. If it's false, make it true. We're going to add the code here now to actually open and close the inventory, and then pause the game, which I'm realizing this script is almost identical to the pause menu, but whatever. Underneath the private bool isOpen, we're going to make a public game object called inventory. And then here I'll say inventory.setActive true. And then here we'll say inventory.setActive false. I really do think Copilot got significantly worse in the last update. I do not know what that's about. It's literally like wrong every time right now. This is crazy. But anyways, so I want to pay attention to this fact real quick. Notice if isOpen is equal to true, then we set active true. If isOpen is equal to false, we set active to false. So it's fair to say that whatever isOpen is, inventory.setActive should be the same, which is why on this line we have said isOpen here. So if inventory is active, if isOpen is true, this value will be true and it will open the inventory. If it's false, this value will be false and it will close the inventory. Just like the pause video, we also want to stop the whole game when you open the inventory. So in our open inventory function, we're also going to say time.timescale equals 0. Timescale lets you set the speed of your game's time. So if it was 2, it'd run twice as quick. If it's 0.5, it'd run half as quick. If it's 0, it's going to completely freeze. When I close the inventory, I want to set it back to what it was. So we'll say timescale equals 1. And toggle inventory, we're going to create something called a ternary, which will let us basically say if isOpen is true, then timescale is going to be 0. If it's false, it's going to be 1. So a ternary says if this value is true, do this. If it's false, do this. So this is very similar to what we did on these lines before the equal sign. And afterwards, we're just using the values 0 and 1 like we did earlier. But we're using the current state of isOpen to say whether or not it should be 0 or 1. If isOpen is true, it should be 0. If it's false, it should be 1. Back to Unity. We need to make our inventory disabled by default and then make it so the player can press the I button or whatever to open and close it. So with the inventory object selected, I'm going to click the check mark here and disable the inventory. It'll still be there, it's just disabled. And then we're going to go to Edit, Project Settings, and we're going to go into our input actions here under UI, and we're going to create a new one called Inventory. Actually, I'm going to call it Inventory Toggle. If you haven't messed with the input actions before, you have these things called action maps, which are things you can control, and then actions, which are things that that thing can do. So you can control a player. A player can move, they can look, they can attack, they can interact, blah, 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 blah. And under an action, you tell it how it can do that thing. So how can a player move? Using left stick or WASD or the joystick. How can they jump? With the space key or the south button or the secondary button on an XR controller. With our UI thing here, in our inventory toggle, we're going to add one for how to do it on keyboard and one for gamepad. So under no binding here, we're going to select keyboard and mouse, and then path. Hello, why did I do that? We're going to do path, listen, and press the I key. It's going to pop up right there. Then we're going to hit plus again, and we're going to do gamepad, path, gamepad. We'll do the select button. We'll say select opens the inventory. This is good. Now we have a way to toggle the inventory with the keyboard and the gamepad. Back to the scene here. To actually plug this into our inventory, let's put the inventory script on the canvas. Earlier, I put it on the player, and then if you didn't catch it, I did remove it from the player because I didn't think it really fit. So I put it on the canvas instead. Your intuition might say to put the inventory script on the inventory object, just like you'd put a player script on the player object. The issue is that when the object is disabled, the code won't run. So none of this code would be able to run if the inventory was disabled. And clearly that's not a good thing. We want this code to be able to run at any moment when the player presses the button. With the canvas selected, our inventory script has a slot called inventory, which is set to none right now. Let's drag our inventory into that slot. Now the last thing we need to do is plug in these buttons properly. The only one that should respond to a button press is toggle inventory. So to make it respond to a button press, we're going to say input action dot callback context ctx. And then I'm just going to add a little thing that says if ctx dot canceled return. This means that it's going to exit. Return means stop doing the function. So, and canceled means you release the button. So if you release the button, then stop doing the function. It's not going to actually run any of this, which is good. We don't want to run any of that if you release the button, only when you press it. Let's go to our player object, player input component, go to events, UI, and look for inventory toggle. We're going to drag in our canvas, then go down to the inventory component and select toggle inventory. Let's save the game. Let's try it out. If I hit I, it doesn't do anything. I might not put it in right. So I could definitely work for the pause menu. I might just switch it to the pause one. Inventory, Unity UI stuff would be really weird. Let me check all of the consoles and everything in my edit project settings. I know this worked earlier for the pause button. I didn't change anything. Here, I'll get rid of this just in case that's breaking it. Because that's the only thing I didn't do in the pause menu. I just got rid of the CTX cancel part. Theoretically, I should need that, but who knows. Code sometimes can be very, very odd, and you don't really know why it does what it does. There's always a reason. Yeah, for some reason that broke it. Okay. There's always a reason for why something happens in code, you just don't always know it. The computer is never wrong. It's just sometimes hard to understand why it does what it does. Okay, this is good. We have a bunch of things done now. We have items that we can collect that go into a hidden inventory list that we can't access because it's static. And then we have a placeholder inventory that we can open and close by pressing I. This is good. We're almost there. Let's quickly, let's just finish it. So last thing we need to do is just make this inventory a actual depiction of what's currently in this inventory items list here, and then make it so we can click on something to get rid of it. We're probably not going to talk about dragging and dropping things in this video because that would add another 40 minutes, but I might make a separate video for it. Either way, no one's going to judge you if your inventory is not perfect. Let's do the current representation of things. So basically what we want to do is when we start the game, we're going to see what's in our items array. Because if we load from another scene, there's going to already be something in this list here. Or I keep saying array or list, it's basically the same thing. When we start the game, we want to go through whatever's already in the list and populate it to our inventory. And then from then on out, anytime we grab an item and add it to our list, we want to also add it to the inventory. So what we're going to do right now is open the inventory back up because we're going to do a couple things. In the inventory here, we want to make it so these slots can actually have something in them. The first thing I'm going to do is create a prefabs folder because we're going to create a couple of prefabs here. We're going to create one for the inventory slot and one for the item that's in the slot. So I'm going to take the first slot here and drag it into my assets prefabs folder that I just created. And it's going to turn blue. The text is blue now. That means that this is an instance of a prefab. If I make changes to the prefab, it'll change the instance as well. This is good. This is what we want. I'm actually going to delete all of our other slots, and I'm going to duplicate the prefab instance now. Now these are all an instance of the same prefab. Changing the prefab will change all of the slots, which is what we want. We want to be able to make changes to one and affect all of them, because all slots are identical and nothing should change when we change, all slots are identical, and if we change the base, we want to change all of these. Note that I can individually change one of these, and it doesn't affect the others, because these are the instances, they're the copies or whatever. If I change the original, it'll change all of them, but if I change just one of them, it won't change the others, which is exactly the behavior we want. In our slot prefab, we're going to make it so, okay, it looks really weird in this view, so we're not going to look at it in this view. If I actually right-click one of these slots, and I click prefab, where is it? Open asset in context, I can actually edit the prefab instead of the instance, but it looks like I'm editing the instance, which is really helpful because we can see the others change as well. And also, it doesn't have the weird thing that this did. Anyways, arrow here is another way to do it. We want to add under the slot, we want to add a child that's going to be the actual item itself, an item representation. So let's right-click the slot and then click UI image. We'll see add one to all of them. We're going to call this item. Now, we already have an inventory item instance script, but we can't add this because this refers to an item in our world that we can interact with and touch and stuff like that. This isn't our world, this is our UI. In Unity and in games in general, UI and the world are typically different things. Notice that our item instance here, the triangle thing, this has a sprite renderer. And notice that UI elements have image components. They're both different ways of rendering. One of them is rendering for UI, one of them is rendering for the world. And we want to render for the UI. So just this old thing is just not compatible at all. These triangles, again, work great for what we want to pick up items or whatever, but they're not going to work for actually displaying them in our inventory. So what we're going to do, go to slot here, the item here. I'm going to drag this item into prefabs, make this a prefab as well. And now all of these slots should have an item prefab in this thing. What we're going to do is we're going to make this item prefab an inventory item that exists only in the inventory. So we're going to go into the inventory scripts folder and create what is hopefully our last script by right-clicking, creating MondoBehavior script, and calling this, I'm going to call it inventory item instance, which is a little confusing because we have inventory item instance and we just have item instance, but you'll have to stick with me for a minute. So this item instance and the inventory item instance aren't going to be too different. The major difference is going to be that this one relies on a sprite renderer, this one does not. Let's get rid of everything here. The inventory item instance is going to have a public item data like the other one did. And then it's going to have a private void awake where we're going to assign the sprite like we did before. But in this old one, we assigned it using a sprite renderer. And this one, we're going to assign it using an image component. But before that, we're going to do the require component. And we're going to do image instead of camera because I don't know why it would be camera. We're actually also going to require a button. We're going to use Unity's built-in button system to make the item actually do something in the inventory. So we're going to require this thing has an image and then it has a button. And then under here, like we said, private sprite render SPRT here, we're going to say private image underscore image. And then in awake, we're going to say underscore image equals get component image, and then underscore image dot sprite equals data dot sprite. Again, this syntax here is very similar to what we did in the other script. In fact, both these scripts are almost word for word the same thing right now, just switching out the words sprite render for the word image and the button thing. In our item instance, the other thing we did was an onTrigger enter2D that would let us add the item to our inventory. We don't want that. There's no purpose of that here. Instead, what we're going to do is add a function called public void use. And this is going to allow us to actually use the items. I'm not going to get a crazy detail into how to make the item behaviors work right now, but I'll start with a very simple like starter how you would do it. But first, let's get the inventory thing actually set up. The item here, remember, we're editing the item prefab right now, so this is all safe. We're going to add the inventory item instance script, which is going to add the button while it's at it. Note that when I add to this object here, these blue lines came on the left side of the inspector. That means that right now we just added something to an instance. If I wanted to edit the prefab, I'd click the arrow here. We want to apply the changes from the instance to the prefab though. So at the very top, under prefab item overrides, let's just click apply all. And the blue lines disappear. So now we've applied changes to prefab. Let's stop working in an instance and click on the arrow to go back to prefab. So this is the item thing right here. I know this is starting to get pretty confusing. We're almost done. So all of our items have an item instance and a button. Data is set to none. That's fine. We're going to have it get assigned later on when things get added to our inventory. What we want to do now is make it so when we click something, it will theoretically use the item. To do that, in our buttons on click here, we click plus, and then drag in our inventory item instance. No function, and look for the one called use that we created. Now it'll call the inventory item instance use function when we click the button here. Really quickly, in our item data class, let's add a public Unity event called item behavior. And then in our inventory item instance script under use, we're going to say data.itemBehavior.invoke. I will very briefly at the end of this video talk about how to set this up, but if you're familiar with Unity events, it shouldn't be too hard. The only slight issue is that Unity events on scriptable objects, like our items, these Unity events here, they exist outside of the context of any given scene, which means that I can't, for example, take my health potion here and drag my player object in, because my player exists in the scene and the health potion exists outside of scenes, so I can't drag that in. I could only drag in other objects that exist outside of scenes. Like I could drag in a prefab, or I could drag in another scriptable object, or I could drag in another scene. I just can't drag in something like a player instance or an item instance or something like that in my scene. But if you understand how scriptable objects work, you might be able to start setting one of these up. Anyways, let's disable inventory. Go to inventory slot here. We're going to create an inventory slot script as well that's going to manage the state of the slot and tell it whether or not there's actually an item in it. I do think this will be the last script now, maybe. Having an inventory slot script is also going to help us eventually add drag and drop and stuff like that. So inventory slot script, I'm going to put it on the slot prefab. And this slot script is going to do is we're going to get rid of this. We're just going to add a function called add item, or we'll call it set item. This function is going to take an item data item, and then we're just going to say transform.getChild0, which means get the first child, which in this case is the item in the slot here. And we're going to say dot enable. We're going to say set active. Where is it? Game object dot set active true, and then we're going to say that actually should be enough, I think. Item instance is going to call this when it wakes up, but we'll change it to on enable, which means that when it becomes active, like we're doing right here, it's going to rerun this. It's going to see if there's any new items that it should have. But before that, we're going to say transform.getChild0 dot item. What's it called? We're going to do get component item inventory item instance dot data equals item. So whatever we apply in here, it's going to set the data variable equal to that item, and then it's going to set the object to be active, which is going to run the onEnable, which is going to set the sprite. Oh, this is the wrong one. Which is going to set the sprite. Oh, this one should be onEnable. I changed the wrong one. So it's going to set the sprite based on the current item that's in data, which was assigned right here. And once it becomes active, then we can click on it and everything. Very quickly though, set item actually assumes that the user puts an item in. The user at some point might want to say something like set item null to get rid of a current item. So to do that, to accommodate for that, instead of set active true, we're going to say if item is not equal to null, set it to true, otherwise set it to false. This is a ternary. It means that if this statement evaluates to true, it's going to return this. And if it evaluates to false, it's going to return this. Which actually is kind of funny. In Unity, a scriptable object or a mono behavior saying if it's not equal to null, you can actually simplify this syntax by just saying this instead. And this will be the value of item will be true if it is not null and false if it is null, which is kind of funny because if this basically we're saying if this is true, then return true. If it's false, return false, which is just the same thing as saying set it equal to itself. So we're saying, but it makes more sense if I explain it step by step than just writing it here. So set active item sounds really weird because item is not typically a bool, but this says if it's true, set it active. If it's false, set it inactive. Go back to Unity now. With the inventory slot instance thing here, my slot should have the inventory slot script. This is good. I'm gonna make it so all slots are the items in the slots are unactive by default. So all of our slots here, let me reactivate my inventory real quick. They all have items that are by default inactive, which is good. We want that. And we're gonna make it so in our code, it'll actually go through all the items in our inventory and apply the set item function properly. We're almost there. We're almost done. So let's do that real quick. But first, let's go into the game actually and recap where we are, because nothing in the game has changed. We've just been setting up code for basically, which can be disheartening sometimes. But trust me, it's all been for something. Press I, opens the inventory. Nothing here has changed yet, but it will work in just a little bit. Even after collecting items, nothing changes. Let's show it real quick though. We're gonna go into our inventory script, and the way this is gonna work is every time we open the inventory, we're going to evaluate what's currently in it. And we're going to go through and set all the values based on what it is. Sorry, my cat just curled up on me. It's really, really cute. Anyways, I'm going to create a private void called evaluate inventory. And then what we're going to do is go through all of the user's items and set the slots to each item. And if there's not an item in the slot, set it to null. So here we're going to say, we're going to go through all of our items here. We're going to create an array. Or sorry, we're going to go through all the inventory items. Our inventory currently has 24 slots in it. I can tell because this says 23 and the first one doesn't have a number. So we're going to create a for loop that runs 24 times. To do that, we're going to write for int I equals 0. I is less than 24 plus I. What the heck? Oh, I didn't come out for some reason. I is less than 24 plus I. Right now, it doesn't really matter to you why this works, but hopefully you can tell from the from context that whatever number I put here is how many times the loop is going to run. If I put 100 here, it'd run 100 times. If I put 60 there, it'd run 60 times. If I put 7 there, it'd run 7 times. Anyways, we're going to do here now is we're going to say go through all of the inventory slots in this object and run the set item function for the given item. Let's do this. So first of all, let's grab all of our inventory slots. We're going to say we're going to do this at the very beginning because this might be an expensive function to run over and over again every time you open the inventory. So we're going to create an awake function, and above that, we're going to create a private inventory slot array called slots. Now, an array stores multiple values. A list also stores multiple values. The difference is that you can always add and remove things from a list. An array is kind of like set. So like previously, we've been using add to add things to a list. You cannot add things to an array. You can only set an array. Like in our awake function, I'm going to say slots equals get components in children inventory slot. This will get all the inventory slots in the children, which is all of these are the children, obviously. They all have inventory slots. So this array of slots is going to have 24 children in it. But later on, I can't like add or remove things from the array. I can only add or remove it if it's a list. So if it's constantly changing and you're adding or removing things from it, you should use lists. If the size stays the same, you should use arrays. Real quickly, I just realized our inventory item instance, after we use the item, we should probably get rid of it. So let's really quickly do inventory.items.remove data. Anyways, I just realized a reason that's gonna break. We'll fix that in a second. Here, inventory slot, again, it has this set item function. So all we're gonna do is say slot at I dot set item, and then item data item here is going to be items at I. And then we're going to do a question mark in case it's null. We're going to do 2 question marks actually. And we're going to say, no, actually, no, I just realized. Okay. What we can do is say items dot count is greater than or equal to I question mark I question mark null null. This part I'm kind of writing on the fly. It may or may not actually work. What I'm trying to do is, let's say you have 24 inventory slots. But you only have 10 items in your inventory. It's going to run this code 24 times, and for all 24 slots, it'll be just fine. Once it tries accessing an item that doesn't exist, like the 12th item in an array with only 11 items, it's going to freak out. The code we're writing right here is supposed to say, if the item tries going beyond the actual amount of items in the list, just return null instead. We'll see if this works. I don't have a lot of confidence that'll work. I might need to do greater than instead of greater equal to. I'm not sure yet. But anyways, what the heck? It removed like 2 things at once. That was weird. Whenever we open our inventory, we want to evaluate it. Whenever we toggle it, if isOpen is true, then we want to evaluate it. If we close it, we don't need to evaluate it, obviously. But finally, we want to evaluate the inventory when we use an item, because it's going to remove it from the list. So we'll say find first object by type. That's not right. Inventory. Oh, my inventory dot eval. Hello. Did I make it private? I made it private. Make it public so I can access it from the script. Dot evaluate inventory. Also, I'm realizing evaluate inventory is kind of redundant. Actually, all of these are, because the script is inventory, but whatever. So find first object by type inventory dot evaluate inventory will call this every time we use an item. Now this sounds kind of inefficient. We're evaluating the entire inventory, all 24 slots, whenever we use a single item, and it is kind of inefficient. But I don't really care, because all set item does is potentially set the item as active or inactive, which is going to run this line of code. It's not really that complex. It's not going to take very many like microseconds. It's not going to like slow the game down at all. So I don't really think it matters really too much. Let's see what happens right now. Let's play the game. Whenever you add a really complex feature or any feature at all, you want to test it. So we're going to start by testing it with no items. Immediately, it broke. Index was outside the bounds of the array. That's the error I was worried about. So yeah, I should have used less than, not greater than. I don't know what I was doing there. So no, what? We want to say if I is less than the number of things in the array, right? Maybe we need to do -1. I don't know. I'll figure it out. Let's see if that works. Sometimes you really just have to mess with the code. Like, I'm sure if I stopped and thought about it for a little bit, I really could figure out what the correct logic is behind this. But I would, in this case, rather play around with different settings until it just works. There's really not that many combinations. I don't know if this is definitely less than. I don't know why I thought it could have been anything else later. But it's either -1, +1, or nothing there. We're just gonna see which it is. It was not -1. Let's see if it's +1. If this doesn't work, then we can start logicking it. Okay, that is also breaking. Let's see. So I hit the wrong button. So I is gonna start at 0. ims.count is gonna be like 0 right now. Is 0 less than 0? No, so it should be equal to. But that's what +1 should have done. You're gonna have to give me a minute to figure this one out. This is good though, because you can hear the debugging logic behind why I'm confused. This is not working. Yeah, wait, no, that's making sense. So why is it doing what it's doing? It should be null every time. It shouldn't be freaking out unless this isn't working. I'm pretty sure that should work. Because I starts at 0, and items.count is 0. 0 is not less than 0, so it's going to do the null case here, which is what we want it to do. Maybe I just didn't check this one yet. I checked all cases but this, maybe. It's really yelling at me on line 54. Okay, well, we're going to learn how to use breakpoints. That's pretty helpful to know anyways. So I'm going to put a breakpoint on line 54 by clicking on the red circle here, and then clicking attach to Unity. And then we're going to switch back over to Unity. It's going to ask, for this session, all projects are cancel. We're going to do all projects because this is a lengthy process, and you do not want to sit with this screen more than once ever. So you'll see at the bottom right that it's loading something. It's compiling scripts right now, and we're just going to give it a minute to do that. While it does do that, honestly, I think we're pretty much done. So I'm not sure if there's anything else I want to do while we wait for it to load, except for look at the code and see maybe what we didn't think of. It could be that this isn't working, but there really should be 24 slots, unless I miscounted. Oh, one thing that could improve this code a lot is we're assuming there are 24 slots. Never assume anything in your code. Instead, we could say slots.length to get the exact number of slots, and that honestly could fix our issues with this anyways. I'm not going to save because it's in the middle of something, but I'll just change that first. We never really want hard-coded numbers in our game. Those are always gross. And now this will work perfectly no matter how many slots there are. As long as this is definitely running before this, which maybe it's not. That'll run here. No, it should definitely be happening later on. Let's see, it finished loading. So I'm going to save my changes real quick and go back to Unity. Give it another second. Notice that it still has the pause and stop button here, which means we are still in this mode. And things do take a little bit longer in this mode. With breakpoints enabled, we can actually freeze the game when it hits this line of code. We can see what's going on. It's pretty awesome. Check it out. So, come on, do your thing. Again, things take longer in this mode. Okay. When I press I, it didn't hit the breakpoint, but it didn't error out either. I'm really concerned about the slots right now. Let me try again. Maybe that fixed it. Maybe I was wrong. Maybe there weren't 24 slots. There are definitely 24 slots. I know how to do math. But let's go in our inventory script and see the value of slots, which is 0 right now, and see what happens when we play the game. So notice that slots is still 0. When I press I, it's still 0. So I've been running under the assumption that this code has been working, which has clearly not been. And that is because get components and children by default will not find those children if they're inactive. You have to pass true as a parameter for it to do that. And that is something I did not remember until right now. It's a very weird behavior. But moral of the story is before you start using the debugger, just check the private variables and see if they're actually getting set or not. Now, when we play the game, we'll notice the slots get assigned immediately in awake. And then when we press I, it should open the inventory. No errors. Let's grab the check mark, press I again. We'll see there's a check mark there. And if I go here, check mark is the item that's enabled, which means it has a button. And pressing the button should activate the inventory's item instance use function, which should invoke the behavior, remove the inventory item, and reevaluate my inventory. So let's grab a few more items first. And this is gonna this is gonna break actually. I think maybe not. We'll see. We click this one. Sorry about that. If I click this here, it should use the item, remove it, and reevaluate the inventory, which it seems to be doing almost well. That was weird though. That didn't work properly. Let's check that out again. Let's do one item at a time as a test. Grab the check mark, inventory, use it, close it, open it back up, everything's good. Grab the square, use it, everything's good. Square, use it, everything's good. This one, use it, everything's good. Issues seem to be when there are multiple copies of the same item in the inventory, which I'm not really too surprised about because how things are added and removed from lists. So like, if I remove this one, oh, that was weird. Look at this. We're almost done. This is the last bug we're gonna fix and call it good. So if I collect 1, 2, 3, watch this. I select this. There's still a button there. Hover over it. Everything's fine. If I hit escape, it immediately fixes itself. It's like the reevaluate inventory here didn't work. But for some reason, closing the inventory did. I think I know why. If time scale is 0, that has to be it. Let me test something real quick. See, we're learning things. I'm learning things. You learn things by experimentation. I did not know that time scale is probably what's messing this up, but we're going to find out if it is or not. Click this. Everything there's fine. If I go to the item here, if I hit I for inventory, it gets set properly. Let me try disabling the timescale of the pause functionality. Let's see what happens. I have a feeling the Unity buttons work weird without timescale, but I might be wrong. I might be completely wrong. I might just have to manually do the whatever. Let's see. Select this, click that. I use that up. No, different error. Oh, it knows that one's supposed to be there. Okay, so let's see. It's gonna remove the inventory item, and it's gonna evaluate our inventory based on the items at that position. Okay, this is what we're gonna use breakpoints for again. We're gonna put a breakpoint here and click Attach to Unity. The Unity will pause when it hits that line of code. Let's see what's going on under the scenes. In a second. Okay, I click each one of these three. I have inventory. With the first one, see what happens? Everything froze here. Now we can actually inspect this line of code, see what's going on. If I hover over inventory items, there should only be two. One mana potion and one mana potion. That makes sense because I clicked on the health potion. So it's going to find our inventory and it's going to run the evaluate inventory function. It's going to run 24 times and items 2 mana potions. For each slot, it should set the item. If item is null, like it is here, that's mana potion. It should set the data, which was health potion, equal to mana potion. Oh, I see. I forgot that set item. So item instance here, setting the sprite happens only in awake, which means it has to like be disabled and re-enabled. This should happen in the set item thing. Immediately when we set the item, we should change the sprite to the item sprite that we give it. This is good to know. And this should be sprite render, not. Okay, so when we makes more sense. We set an item, which happens when we reevaluate our inventory. It'll set the item data equal to the item, sprite render of sprite equal to the sprite, and then it will set the thing active if it has an item and inactive if it doesn't. We're making one assumption here though. We're assuming there is an item. If there is no item, it'll try to get the sprite of an item that doesn't exist. It'll freak out. So we're gonna move this part. We're gonna say, actually no, we'll keep it there, but we'll say item question mark item.sprite null. So it's only going to try and get the sprite from the item if there's an item to get the sprite of. Otherwise, we'll get null, which is fine. Null, there's nothing wrong with null. The only problem with null is if you try to get something from null, like the sprite of an item that doesn't exist. Let's try it out. Inventory, close. Okay, immediately, issues. Oh, I said sprite render. I meant to say image. Because that's how Unity UI works, images. UI and game are completely separate things. Let's give it a second. Okay, let's try it out. I did turn off the thing, right? Yeah, I did. So when I press I open inventory, everything's good. Close it. One of these. Good. Oh my gosh. I keep making changes to item instance when I mean to make changes to item inventory instance. Having both these scripts is really confusing. I'm going to change item instance and call it item world item instance. I'm going to right click rename, and then type in the word world here, which is going to rename the script and the class at the same time. Because in case you didn't know, the script name and the class name have to always be matchy. They have to be the same. I somehow crashed Visual Studio doing that, but no matter, we can still test our Unity out. Right? How did I break Visual Studio? And they said this was production, right? Anyways, let's play the game. It doesn't need the editor of Visual Studio to actually do anything. Okay, or it does because it ran this but didn't do it right or something like that because my items are broken now. I love Visual Studio decides to just not work. So 2 of these were health potions and 2 of these were mana potions. Okay, let's try it out. Okay, inventory, close it, nothing happens. Like 1 thing, looks good. Like 2 things, it's good. Let's do third, let's do a fourth. Use the first one, use the second, use the fourth, use the first. Everything there looks good. Let's turn our item instance to a prefab. False item. I'm gonna false world item, and this one inventory item, and then I'll destroy these ones and make these references to prefab instead, so we can make changes. It's the prefab, and then everything would get affected. For organization, I'm going to select all these, create an empty parent, call it items. Okay, I think this is pretty much done now. I'm going to show how you would do just a very, very basic item that just debugs something to the console, and then if you have a question about specific items, I can answer it in person. But this basically works now. Let's I put that one 2 out of far to each. One of those. Stop, start, stop. Okay. Let's add a very basic item function to one of our items. Just very quickly, we're going to go into our item data script because this is a scriptable object. We're going to add a different public void for each of our items. I'm going to call this one debug message. And all it's going to do is do a debug.log. It says hi, exclamation mark. And back in Unity, note this was on our item data scriptable object. And this is the one that has the item behavior Unity event. What we're going to do is go to our items folder here, each of our items here. Item behavior, I'm going to drag in health potion, and then go to item data debug message. This one, I'm going to drag in mana potion, item data debug message. This is the item behavior Unity event, which is a recap. It's getting called by the inventory item instance in the use function. When the user clicks on it, the very first thing it does is invoke the item behavior, which will do whatever you plug in here. If you've ever used player input for Unity events or buttons for Unity events, then it won't be completely foreign. Anyways, let's pick up a few of these. Over to inventory, go to our console, and click one of them. Activates the debug message, which means that this item works. And we could theoretically add other items. For example, you could say something like find first object by type player. If you had some sort of player stats or something, you take health plus equals 10 or something. Make the player's health go up by 10. Or you could say like find first object by type checkpoint and like disable a checkpoint or something. I don't know why you do that specifically. But any code you write in here will work, obviously. As long as you can find reference to things you need to use, like your player or your inventory or something like that, then it should work just fine. I won't get into how to do like moving things in inventory in this video because that really is completely unnecessary for like the level of projects that you'd be doing at this point in the year. Although if you're watching later in the year, then I'm probably wrong. But yeah, in another video, I'll talk about a drag and drop inventory But all things considered, this is pretty advanced anyways, and if you need more than this, it's probably overkill. I doubt you actually need more than this. Um, I do want to remind you, not that I'm not going to say this to everyone anyways, but your games do not need to be perfect. The more you try to make every aspect of the game perfect, the more you narrow in on one thing that's not really that important. Like if you really spent all the time to create a drag and drop inventory with a hotbar and tooltips and all this kind of stuff, you would spend the entire project making an inventory, and then your game would just be an inventory. That's not something you want. So this is a very good basic inventory, and it only took an hour and a half or 2 hours, whatever this was. Yeah, I hope you enjoyed the video, and thanks for watching.